This large industrial site is in Ingolstadt, near Munich in Germany. It is owned by the successful car manufacturer Audi. Despite its size, this is only one small part of the company's facilities for car development. The quality that Audi demands requires major investment in technology and the ability to attract highly talented people. Audi has always understood this, and so it is no surprise that they are pioneering grid computing to ensure their new car development happens in facilities like this, linked across the world. The global automotive industry is highly competitive and moves at a development speed that would have been unthinkable 15 years ago. They were one of the first manufacturing sectors to embrace grid technology as a powerful solution to a very real problem.
In the older days, when we developed cars, if we look back 15 years ago, then we have less virtual capabilities. We have pure hardware-driven developments. So the synchronization of the development process was done by the use of prototypes which were tested, and then the results of the tests were fed back, and then we changed the design. So this is a very slowly process, and if we compare this with the current development of our premium car A6, 1,500 front crash simulations compared with 100 front crash real tests. So we have 15 times more virtual development space than real. So this has changed totally. If we have a prototype test, then we have one kind of prototype which is built with a specific setup. And then you do a crash test, and then you get one result. In real life, accidents are different, so this is only possible if we use simulation, because in simulation techniques you can put cross sections to beams, to welding points, and you can compare how they work in different situations. If you want to establish this process in hardware, you have to build thousands of prototypes, and this is not possible because in typical you have to estimate that one prototype costs approximately 1 million euro. Audi is totally customer orientated, so the customer driven things are fuel consumption, safety, comfort, and these things are very important. We want to match these expectations of our customers, and so we need fast development loops that we meet exactly the requirements of our customers.
Audi have centres across Europe connected into their grid. The sort of simulations Audi must do require vast amounts of data, which is created initially in several different locations. Data integration becomes more complicated because the collaborative researchers produce design data, numerical data and test data. The challenge is to make all this immediately accessible in a virtual environment to the whole product development team, when they want it and wherever they are based. The second challenge is then to be able to dig into the data quickly to retrieve the information they require for their current task.
For example, in the aerodynamics, we have the styling people, we have the CAD people, we have the test people in the wind channel, and we have the analysts. And all these groups of people have to work closely together to get the best form of the car. That means if the styling people has created a new form, it is necessary for the analyst to get this data, because they have to calculate the drag coefficient and so on. And additionally, the analyst would like to have information from the wind tunnel, what is the result of the wind tunnel, and the styling people have to get both informations to compare the test result and the numerical result. And that means all these databases of these three different disciplines, the CAE discipline, computer-aided engineering, and the CAT discipline, computer-aided testing, like wind tunnel, and the CAD, computer-aided design people or styling people, need the same logical virtual database to have all information at the same time. SIMDAT is a project for us, for the automotive industry in Europe, because data management and especially the data mining is a challenge to be competitive within the automotive industry. We have to cluster 600 CPUs to handle the required computer power for the crash simulation. This is one challenge. The other challenge is for the crash simulation, we produce a lot of data, usually several gigabytes for one job, and we have to handle this large amount of data across the networks, transferring the data, storing the data, and so on. And another aspect is the data mining, the knowledge discovery, because the data are distributed at different locations, and we would like to get additional information from these data, and out of this information we would like to get more knowledge.
Our vision is that we need no prototypes to develop a car which is totally matching the expectations of the customer.
Our aim is to simulate all the problems we have within the car development, and that means we would like to have a situation that no prototype tests are necessary.
And this is only possible by using these grid technologies.
By harnessing existing technology, but thinking clearly ahead about how they use their IT investment to create a virtual organization, Audi have ensured that their talented developers have the tools to be building high-quality cars well into the 21st century.